Today we'll be solving another Leetcode problem. This medium marked, it says crown good meals. Okay, so let's read the problem. We have deliciousness as an array and we are asked to make sum of any two indexes and that sum should be a power of 2. Let's see some examples. 1, 3, 5, 7, 9. So we can have pairs as 1 and 3, which is 4, and it is 2 raised to 2. We have 1, 7, we have 3, 5, we have 7 and 9. We need to return total number of pairs that can be created. Okay, let's check another example. 111, 333, 7. Here 1 can be paired with 3 threes. Then another one, this one again can be paired with a 7 to make it 8. We can repeat this process for the other two ones. Okay, if you have gone through this problem and after reading the problem you will be thinking, you should think and check. If you are not able to think, you should work on hashing first. Hash maps you should work on. After reading the problem, we are sure that we have to find some part which might be in the array or which might not be in the array. And if we are traversing again, we are definitely crossing n. We are making n square. And if we are making as n square, we are sure that we will get a TLE. So for reducing TLE, for not getting TLE, either we have to come up with an approach which is less than n square, which can be achieved by either hashing or something we should have to do. After reading the problem, you can figure out that this pattern resembles with a two-sum problem. But the point is, in two-sum we were provided as sum, one more variable which is k, that find pairs with sum equals to k. Like this we were there. Here we are not provided like this. Here we are provided that the sum should be a power of 2. So let's first understand what is power of 2. So it can be 2, 4, then 8, then 16, then 32 up till, let's check it says 2 raised to 20. 2 raised to 20. 2 raised to 20. If we see, okay, 2 raised to 20. So somewhat we will have 20, 21 values. Okay. Now if I ask you, let's say this one, 111, 333, 7. 111, 333, 7. If I ask you to pair this one and find out how many pairs that it can make, what I'll do, I'll try to make pairs. I'll try to make my sum as a power of 2. Power of 2 we are storing here. Let's say we know that we'll be storing somewhere. So we can make 2, 4, 8, 16, 32. So 2 minus 1, 1 should be present here. Okay, we have 1, we can make a pair. This one can go with this one can go with this one. We get 2. Now now let's move to 4. Can we make a 4? Yes, we can make a 4. How we can make a 4? We have 3 threes. We can make 3 threes, so we'll have some answer. We can make some pair. Now can we make 8? Yes, we can make it. 8 minus 1 is 7 and we have 7. Now we see 16 minus 1 is 5. Do we have a 15? No, we do not have a 15, and so on. So one thing we can see that, okay, if at order of 1 times we are able to look up in our array, then we'll definitely be able to get our answer under the provided time limit. Okay, and since these can only be 21, 20, 21, so we can say this is a constant, or you can say n times 21 times something like will be our time complexity. and we will be storing these in one of our vectors, and we will be storing this in a map. Okay, let's just try to make answer how we will be creating it. Okay, first of all, let's say our map is currently empty. Map is empty now, and we'll pick our values one by one. Okay, so let's start with the 0th index. Do we have one? Sorry, do we are at 0th index, which is 1. So we'll try to make this sum as 2 minus 1 first. We'll be traversing across this. So it says 1. Now, do we have 1 in our map currently? No, we do not have 1. Okay, no issues. We go to 4. Do we have 4 minus 1, 3 in our map? No, we do not have. Currently we do not have. So again, answer is not updated. Now, after this iteration for 1, we'll insert 1. And why we are inserting 1 is very important. We are inserting 1 so that the negative part of it, or you can say the remaining part of the sum, can be achieved once we are at 3, or once we are at 7, or once we are at the next 2. Okay. Now after first iteration, our map is not empty. Now map contains 1 time. Okay, now we are at this first index. Now we again ask the question, can we make a 2? So we'll check 2 minus 1, 1. Is it in our map, and how many times is it in our map? It says okay, 1 is in the map and it is 1 times. Can we make a pair? Yes, we can make a pair. So answer is updated to, I will be writing answer here as answer is updated to 1. Okay, we ask same question to 4. Can I make a pair with you? Yes, I can make a pair with you. 4 minus 1 is 3, but currently I do not. I'll ask map, do we have 3? Map says no, we do not have 3. So we say okay, answer cannot be added anything now. So this one will also be traversed across all 21 values. We won't be finding anything. Now after this iteration for 1 is completed, we'll again add one more 1 to our map, so that for our upcoming values we do have a pair. So now we have 2 1s. Now we'll again go with this one. We'll ask okay, can I make a pair with 2? Can I make a pair sum as 2? Okay, I can make. So how many do ones I have? You say you have to look at the map. So how many ones I have? We have 2 ones. So how many pairs I can make? I can make 2 pairs with 0 index and 1 index. Okay, so 1 plus 2, which gives us 3. Now we'll update our 1 to 3. Also, when I am updating, I am making sure that I have traversed with all. Now we'll check with 3. 3 goes to 2, so 2 minus 3 is minus 1. We cannot make a sum, we cannot, since we do not have this in a map. Then can we make a pair sum as 4? 4 minus 3 is 1. And how many ones we have? We have 3 ones. So we can make 3 pairs. Okay, we can make 3 pairs. Now we have 1 plus 2 plus 3. Also, we should insert 1 3 in the map. Okay, now we go back. Now we move to next 3. Okay, and also this 3 will be checked against 8 minus 3 5, which we will not find. 16 minus 3 is 13, which we will not be finding, and so on till 2 raised to 20 21 values. Let's move, and then this 3 will be inserted to our map. We move to next 3. Once we move to next 3, what do we find? 3 minus 2. Can I make something? So 2 minus 3, can I make something? No, minus 1 is not in the map. We can't make anything. Now 4 minus 3, 4 minus 3. Do we have ones? Yes, and how many 1 we have? We have 3 times 1. Okay. So we can make 3 pairs, and you can also see that this 3 can be paired with these 3 ones. Okay. Now can I have 8 minus 3 as 5? No, we do not have. Same with 16 minus 3, 13, we do not have. At the end we'll update this and move. Now we have this 3 coming up. This 3 will again ask 2 minus 3. 2 minus 3 is minus 1. Can I make a pair sum as minus 1? Obviously we cannot make. Then 4 minus 3, 1. Yes, we can make. How many ones we have? We have 3 ones. Okay. So let's update add this to an answer. Now it will again ask 8 minus 3. How many 5 we have? No, we do not have a 5 itself. So we can skip it. After 16 minus 3. 16 minus 3 is 13. Same till 2 raised to 21. After this it will be updated and 3 will be inserted. So 3 times 3 will is their answer. 3 sorry, my bad. 3 3s will be updated to our map. Okay. Now let's check with 7. So 2 minus 7 minus 5. No, we do not have minus 5. 4 minus 7. 4 minus 7 is minus 3. Do we have? No, we do not have this in a map. 8 minus 7, it is 1. And how many ones we have? We have 3 ones. So all these ones can be paired with this, with our 7. Yes, it can be. So and again a 3. Now we move. 16 minus 7 is 9. Do we have 9? No, we do not have 9. Same with 32, then the rest values. Now let's now we are at the end of the array, so we can just take out the sum, and sum is 3 3 6, then 9, then again 3 12, then 3 15. So answer is 15. Let's check. Yes, the number of pairs are 15. Now the main issue that we solved is that since we are storing everything in a map. Okay, also one more thing, at last 7 also will be inserted as frequency 1. So what did we solve with this? We solve n square. We reduced our lookup of n square to order of 1 because we used a map here. Okay, and how we will be storing these values? We will make a vector array. Let's check the code, and in the code I'll be explaining again. Okay. The question also asks us that there can be many ways, there can be many pairs, so we should be modding the values. Okay, so we have to mod it with 1e9 plus 7, so that mod I have created. Let's first make a vector which is power of 2 that I have given. Okay, now we need to insert all the powers till we are provided 0 to 2 raised to 20, which is 0 to 20, that is 21. Okay, now first I have pushed 1, then I have made a vector of power of 2. So power of 2 dot push back, power of 2 dot back into 2. What will be, it will be doing 1, then 1 into 2, which is 2, then 2 into 2, that is 4, 4 into 2, that is 8, and so on. Now I have created an answer, and I have also created a map. I will be traversing in nums. Remember, I will be traversing all values in nums. I have changed deliciousness to nums. So I will be traversing every value of nums. And what is our total? Our total is power of 2. Remember, 2, 4, 8. Now can I make a 2 minus 1 1? If yes, I can make. Then there will be some values in the map. So I have checked that if a map of total minus a is greater than or equal to 0, that means we can make. So for the first time you won't be getting anything in the map. Okay, So map of total minus a is greater than 0. Now if value is there, so answer we will be adding answer equal to answer plus map of total minus a modulus mod. Now remember what I told, after traversal in the vector power of 2, we will be adding this value to our map. Remember, this is a very important step. Why we are adding? We are adding because after, if this is not added, our map will always stay empty. We won't be finding any pair. Let's say we need to find pair for this 3. We should have kept some values what have come across. That is why we need to add this. We have to add this, and then at the last we are returning answer. Most of the people will first make a map. If you will be making a map first, then once you will be traversing in 1, you will be making some pairs with 3. Then once you are again at 3, you will be again making some pairs with 1. Then you have to do something else because you will be counting them as twice. So this is a very good technique that you are adding at later stages, which is, I think, is a better approach. Okay guys, this is for this video. Do like, comment, share, subscribe. Thank you guys. Meet you in the next video.